Okay, so for the second part of the example, it asks us to use the graphs of f of x and g of x to graph the quotient of the function. So f divided by g of x is equal to f of x divided by g of x. And if you remember from the warm-up, this actually gave us a rational function. And so a couple of things that I know I will see is, first of all, I'm going to expect an asymptote to exist in the graph because the denominator has a value of x that can make the denominator equal to 0, and that value of x is equal to 0. And we'll actually look at the functions as well to help us recognize graphically when you might get an asymptote in the function. So, first of all, because it's the quotient of functions, we're going to be dividing the y values, so that's something to think about. And you have to be a little bit more careful in this case because the order of division matters. So I'm dividing f of x by g of x. So I need to make sure I'm dividing the blue graph by the red graph. So I need to be more careful when I'm actually trying to graph this function. So one thing to consider is if your numerator value is equal to 0 when the denominator is not equal to 0, then what that indicates is that the entire quotient function is actually equal to 0. So in other words, if f of x is equal to 0, and I'll draw this down here, if f of x is equal to 0, then that means that f of x divided by g of x is equal to 0 over g of x, which is equal to 0. So wherever the numerator of the function is equal to 0, then that means that the quotient of the functions will also be equal to 0. Okay? The second part of some of the things you need to consider is if the numerator of the quotient of the functions, so if f of x is equal to positive or negative 1, then the quotient function will end up being the reciprocal of the, it would be a reciprocal value, which is 1 over g of x. So I apologize for that. So wherever you have f of x equal to plus or minus 1, you end up getting the quotient of functions equal to plus or minus 1 over g over x. Similarly, if you have the denominator equal to plus or minus 1, then the quotient of the functions ends up being plus or minus f of x. So what ends up happening here, for example, is if you have g of x equal to 1 or a negative 1, then f of x divided by g of x would be equal to f of x divided by either positive or negative 1, one or the other. And so if you simplify this, you get plus or minus f of x. So that's something else you need to consider. The other thing you want to think about is because you have a denominator, any value of x that will make this equal to 0 will end up creating an asymptote in your graph. So you can have asymptotes as well. So that's something to think about. It'll cause some restrictions in your function. So let's actually try to graph this. So I'm going to divide the blue graph by the red graph. So let's try to find some values. So if I divide the blue value here by the red value here, this is 0 divided by a negative 3, and so that'll give me 0, so there's a value there. Here I have a value of negative 4 divided by a value of negative 2. So negative 4 divided by negative 2 gives me positive 2, so there's another value there. Then I have negative 6, and notice that I'm following the blue graph, because that's the numerator function. And then I look at the red graph, which is the denominator function. So if I continue here, I have negative 6 divided by negative 1, which is equal to positive 6. Okay, the next one I have negative 6 again divided by 0. So remember that you can't divide by 0, it's undefined. So what that tells me is that there is an asymptote along the y-axis where x is equal to 0. And I sort of expected that based on the original function that we had started with. Remember right here that we are expecting x equal to 0 to be the asymptote of the function. Okay, so what that tells me is the left-hand side of the graph looks sort of like that. Now there's a right-hand side to the graph as well, to the right of the asymptote. So let's continue with our blue graph. So here's another point at x equal to 1. So I have negative 4 divided by 1, which is equal to negative 4. Let's look at x equal to 2. I have 0 divided by 2, which is equal to 0. Remember, I'm looking at the x coordinates to find corresponding y coordinate. Let's look at the next one. I have 6 divided by 3, which is equal to positive 2. And so on the right-hand side of the graph, I have something that looks like, or the right-hand side of the asymptote, I have something that looks like this. And that's sort of what I was expecting because it is a rational function. And there you have it, a restriction on the value of x that's in the denominator, since you can't have x equal to 0. And there's a rational function that I was expecting to see.